All right, hello guys. I apologize that I could not be there in class today, so instead we're going to be doing this video. We're going to try to keep it under 15 minutes. Throughout this video, I'm going to ask that you pause it occasionally if possible and actually do some of this on your own. So make sure that you are actually doing that and not just simply writing down whatever's in this video. Take the time to actually do all of the notes all the way through. If you want to watch this video all the way through and then go back and do those examples, the answer key can be found on Canvas. It's under the weekly packet, and you can fill in the stuff that is not necessarily covered in this video, but make sure you try it yourself first. So first up is the warm-up. The warm-up asks, make a list of the first 10 perfect squares. Keep in mind the perfect squares were like, what's 2 squared? 4. What's 3 squared? 9. What's 4 squared? 16. That's what it means by the perfect squares. So I'm going to let you go ahead and finish that out with the rest of those ones. Again, you can pause the video and then fill in those, or you can come back and fill those in later. Sorry, page jumped a lot. Okay. But what we're going to be focusing on today is simplifying square roots. Now, yesterday, all the square roots that we looked at were perfect square roots. So 4, is listed up here in the warm-up. 4 is a perfect square, which means I get a perfect whole number. What if I get something like the square root of 8? Well, that's not listed up here in the perfect squares. So sure, you could type that into your calculator. You're going to get, 2 point something, right? But when you're asked to simplify, you're not asked to find the decimal value. You're actually asked to just simplify that square root. So if you give me the decimal value when it asks you to simplify, I will not accept it even though it's the right decimal. You should actually be simplifying it. So what does it mean to simplify something? First off, it means that there are no perfect squares in the house, we'll say. So inside of here, there are no perfect squares. And we'll elaborate on that in a second. The third rule is that all variables under the radical only have a power of 1. So we'll say all variables in radical have power of 1. If they have anything above the power of 1, then we should be using our rules from yesterday. Like if I have x to the third, you say that I have 3 x's. How many pairs can you get? You can get 1 pair, they move out, and then this sad, lonely guy is still inside. That is simplified. This is not simplified. So that's kind of what that one means. And then the last one says there are no radicals in the denominator. Now, this is not a rule that we will see often, but it is a very important rule, especially if you go on to higher math classes, because you will get into, and we'll touch on it a little bit, but rationalizing denominators, which basically is this principle of having no radicals in the denominator. So if you have an example like 1 over the square root of 4, that is not simplified. You should get rid of that square root and make it a 2, and now there are no radicals in the denominator, and you're golden. So let's talk about an example that's simplified. Something that would be simplified would be like this. If I have a 5x, 2x. So let's look at the first rule. No perfect squares in the radical. Okay, well, in the radical I have a 2. That's not a perfect square. Check. All variables in the radical, that's an L there, kind of looks weird, have a power of 1. Okay, well, here's my variable in my radical. It has a power of 1. I'm good. There is no radicals in the denominator. Well, there is no denominator, so check. If I go into the second part, it says not simplified. Here's an example of something that's not simplified. Would be 50x squared. First of all, 50 does in fact have a perfect square in it, because 50 could be rewritten as 25 and 2, and we'll talk about that in just a little bit. And then my exponent is higher than 1. That's a problem. This is not simplified. We should take this further. So let's talk about that 25 and 2 that I mentioned up top here. It says you can simplify radical expressions by separating out perfect squares. Okay, factors from the radicand. So if I look at this 8, right, think about what factors multiply to 8. Well, let's see. I know that 4 times 2 gives me 8. Well, if I split that up, very similar to what we did yesterday, if I split that up into the square root of 4 and the square root of 2, well, 4 times 2, that's still the square root of 8. I haven't changed the value. But the square root of 4 is a perfect square, just like we listed up above. The square root of 4 becomes 2. And then this square root of 2 is not a perfect square, so it's just going to stay in the house. So really the answer I'm looking for here is a 2 square root of 2. Now what gets a little bit tricky is when you get into some bigger numbers like this, because you need to decide what numbers, or what perfect squares are in 128. Now, some of you may choose smaller numbers, like I know that 4 can go into 128. So I could split this up and make it a 4 and a 32. That's absolutely fine. But then 32 can yet again be split up with 4 and become a 4 and an 8. And you can kind of see it's just going to be kind of a continued pattern. The 8 can be broken up and it gets a little crazy. So what I recommend doing is trying to look at the perfect squares, hence why we listed them up above, and start with the biggest options. So 121. Does 121 go into 128? Not quite. I can't take 128 and multiply it by something. Then I try 100. 100's still not going to work. I try 81. 81 gives me a decimal. Again, all I'm doing is 128 divided by 81. Doesn't work. Then I say, well, what about 64? Okay, 64 works. That's good. So I can make this 64 times 2 gives me 128. So this one works, and it's my biggest option. The square root of 64 gives me 8, and the square root of 2 is kind of a dead end. So always go with your bigger options first. And as I said, I kind of go back up to my perfect squares. That's why we did them as a warm-up. And I start with my biggest options. So 108. First off, I try 100. Doesn't work. Okay. Then I go to my next one. 81. Doesn't work. Okay. Then I go to 64. Still doesn't work. So I keep going down until I hit one that works. 49. Nope. Doesn't work. Then I try 36. Ding, 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 ding. This one works. This one gives me a whole number. It gives me 36 and 3. Okay, well, the square root of 36 becomes 6, and the square root of 3 becomes, well, just square root of 3. Okay, so now you have a couple of examples, and here's one of those moments that I'd like you to pause the video and try to go and do some of these on your own. A reminder, I would kind of set up these division things. Okay. Now, if you start with 24, I probably wouldn't try to divide it by 49 because obviously that's too big. Start with numbers that are reasonable, like 16, that doesn't work. Maybe 9, that doesn't work. Maybe 4, oh wait, 4 works. So keep trying numbers until one works, but start with the biggest options first, because if you start with small numbers, you're going to end up having to do a lot of them in order to fully simplify it. All right. In the meantime, I'm going to go ahead and move on to the backside. So again, you should pause the video at this point if you have not done so already. Pause the video, go through those last couple of examples on the front, work your way onto the backside until you catch up with me at K. Now at K, what's unique about that is we start introducing variables. Now the variables I stress here are no different than yesterday, but it'll be a nice review in case you didn't fully understand yesterday. Start with the 50 just like we did on the front. I'm going to break 50 down into 25 and 2. 25 times 2 gets me back to 50, but 25 is the perfect square of 5, so I can simplify that down to a 5 square root of 2. Now the x, think back to what we did yesterday. We said we have 2 x's. How many pairs can I make? I can make 1 pair. Was there any left inside? No. So now that would be my final answer. If I pick one like n that's a little bit longer, don't be intimidated by it. Start with the 200. Okay, 200. I start dividing it by things and I say, okay, well, if I go back to my list of perfect squares, I could try 200 divided by 121. Not going to work. Let's try 200 divided by 100. Ding, ding, ding. That one works. So let's split this up into 102. Square root of 100 becomes 10. And the square root of 2, well, that becomes really nothing. So we just leave it as the square root of 2. That is not a perfect square, so just leave it as is. If it is a perfect square, like 100, take it out of the house and make it 10. Then we go through the variables. Again, if you still like to do it old school and write out 6 n's, you could. Circle how many pairs you have. I have 3 pairs, so I'm going to have an n3. With the m's, you could do the same thing. I'm going to end up getting an m4. And then the last one, R12, again, you're starting to get into some really big numbers. So just think to yourself, is it even? Can I divide it by 2? And in this case, I can, in fact, divide it by 2, and I get R6. These are all even exponents, so nothing's going to be left on the inside. The only time you have stuff left on the inside is if they are odd exponents. So right off the bat, I know that these two are going to have something left inside. Now what's nice about I is it's pretty very similar to K. So the 50, I've already broken it down into a 5 square root of 2. But the x's, this time I have 3 of them. So I make a pair and I say, okay, 1 comes out. But this little guy is still stuck inside, so leave him inside. And that's kind of how the variables work. And, again, a little bit of a review from yesterday if you didn't understand the variables very well. Little fun fact, you may or may not want to know this, but this is a square root, right? The square comes from technically there's a 2 right there. That's why we always need pairs of 2. So if I look at like my a's and I have 8 of them, I'm looking for pairs of 2 because it's a square root. If it was something crazy like a cube root, then you'd be looking for groups of 3 or 4 or things like that. But in this case, since it's a 2, it's a square root, square meaning 2, you're looking for groups of 2. So in this case, I have 4 groups of 2, so 4 would be on the outside. If I did the b's next, you have 1 group of b, and then 1 guy still stuck inside. And then just to finish out this last problem with you, the 72, you could break 72 down into a 36 and a 2. That means the 36 becomes 6, and the square root of 2 stays square root of 2. So I need a 6 on the outside and a 2 still on the inside. So very similar to the front, just throwing on that variables, which we did learn variables yesterday, but I know some of the classes were a little more rushed. So when it comes to these numbers, just because it's not a perfect square, it's not like, oh, 4 or 16 or something pretty like that, doesn't mean that we can't break it down into a perfect square and something else. Here's my perfect square. That's a good sign. I get 3. But then the square root of 2 is not perfect, so just leave him inside. Only pull out the things that are perfect squares. Alrighty, so that brings us to the end of this video. Kind of a short lesson, but builds off of yesterday's. So I will remind you guys that I still want you guys going back and doing some of these problems. Okay, just because we didn't do them doesn't mean you can't. All right, here's 2 more. That's a total of 5 that we did not do together. And then once you finish that, again, because this video is only 15 minutes long, and you'll have a 42-minute long class, your homework down here is the same idea. There's problem 2. I don't know where it disappeared to. These are all the same type of problems. Deal with the numbers first. Honestly, if it was me, I would go through and do all of the numbers and figure out how they simplify. Don't even worry about the variables, because the variables we did yesterday and are fairly simple. If it has a power of 1, well, then it just stays inside. If it's an odd power, you're going to have something remaining inside. And then if it's an even power, which I'm not seeing, here's some even powers. Here's an even power. Here's an even power. Here's an even power. Those even powers come out completely. So I don't know why I highlighted that one. That one's not even. But just keep that in mind. Even powers come out completely. Odd powers, something has to stay inside. So good luck with that, and I will see you guys tomorrow.